All right, I'm back here. Okay. So what I was going to do today was go through some of the examples of Hess's law, since we didn't get a chance to go over that in class. So just to remind you what the story is here, let me get rid of that with the dates and everything. Just to give you an idea. So according to the schedule, test 3 is due next Monday. All right, so there won't be class next Monday. So today and Wednesday will just be focused on review. And what I'm going to do is I'm going to take the opportunity today to go over Hess's law, and then on Wednesday I'll go over. Well, I might even start going over the test today, test 3. Now, I just want to make sure everybody's clear about what the story with test 3 is and the way that the extra credit plays in. So all of these quizzes that are in these folders, they're all extra credit. They're not part of homework or anything else. You don't have to do them, but they do add to your grade. Now, per the syllabus, the idea is that you do the quiz and it gives you a certain number of points. And that number of points, or the aggregate of all that, is going to be halved, and that's what gets added to your test score as part of your grade. Is anybody unclear about any of this so far? Okay, now the other thing is that test 3 is just going to be the exact same test as practice test 3. So the best way to study for test 3 is to do practice test 3 under the same conditions as you would on an exam, that is closed book, but with a handheld calculator, and basically do that until you're getting a good score on it, or a score you're happy with, and you should be able to get the same score on test 3. There's no reason you shouldn't. It's the same test. Now, as far as the questions go, there's also videos for each and every question that's present in test 3. And there's 17 of them, and there's 17 videos. All right, or at least around 17. Any questions?
Is the questions going to be the same, or is it going to be repeated?
What do you mean, Michael?
Like, if we do the practice test over and over again, will the questions be the same, or is it going to be like different?
No, the questions will be the same. The numbers and compounds and things will be different, Michael.
All right, thank you.
But I mean, I couldn't be any more, I absolutely could not be any more transparent about this. I just don't see it. Anybody have any other questions just about what we're doing here? All right. So with Hess's law, I mean, these are the ones that people tend to have the most problems with, at least as far as I think the other things we've gone through aren't that bad. It's really just Hess's law that I think is going to be an issue. So I'm going to open up this document here. I'll download it. These are Hess law problems. Now, typical Hess law problems involve, let's look at, let's see, what's a good, I'll look at number 26 first. It's a little bit more simplistic than the other ones. So 26, I'll enlarge this a little bit. There we go. Hopefully you can all see that. So 26 is the one we're looking at. And the idea is that you get these reactions for which you have a delta H value. And the idea is you need to manipulate these two equations in order to come up with the actual equation here so that you can add the delta H's together. Now, there's two rules that we need to go with here when we're looking at Hess's law. Now, I know that, well, you've all done college algebra, right? You had to do it to get to this, excuse me, you had to do it to get to this course. And in college algebra, or even probably pre-algebra, you dealt with systems of equations, right? Everybody's heard of systems of equations, correct?
Yeah.
Yeah, okay. So the idea here is there's two rules. First of all, flip reaction, flip sign. A bit slow again today for some reason. Okay, so flip equation, flip sign of delta H. And secondly, multiply reaction, multiply delta H. Probably should write multiply so it doesn't look like an X. Then you also multiply delta H. Okay. So those are the two rules that we deal with. And it's very similar to what you would have done in systems of equations, where you flip it around an equal sign, it changes, you flip these things from one side to the other to the equal sign, and you change the sign. When you multiply an equation, you have to multiply everything in that equation. Same kind of thing. And the idea is that we're trying to make these equations add together to give the equation that we want. Now, the focus then has got to be on getting whatever's on in each of these equations onto the correct side. Also, we need to cancel the things that aren't actually in this equation. So if you look at the two equations we're given here, you see this sulfur solid by itself, and that's not part of the final reaction. So we know that that's going to end up canceling. That gives us a good clue. But when we're looking at this, what I like to do is I like to look at the reactions and look for the reactions where there's only one of it's the only instance of a certain thing that's in the equation we want. So what I'm talking about here is I look at the equation down here that we want. I see that we have SO3. Now there's no SO3 in the first equation, but there is SO3 in the second equation. Now the SO3 is on the wrong side though. It's on the right hand side when it needs to be on the left. So what that tells me is that I need to flip reaction 2. Now, the other thing that I'm looking at here is I look at the SO2 and I see the SO2 is on the right-hand side, and it's on the right-hand side of the equation we want. That tells me I don't have to flip equation 1, which is good. So what I'm going to do is I'm going to leave equation 1 the way it is for now. I'm also going to ignore the solids, gases, the states here. I don't think that they're particularly useful to us. So we've got S plus O2 gives SO2, and the delta H here is negative 296.8 so far. That's in kilojoules. It really should be kilojoules, not kilojoules per mole. I think they're wrong about the way they've expressed that, but that's another story, I suppose. So SO3 gives S plus 3 halves O2. But you'll notice that what I'm going to do here is flip the sign, make it positive, so make it 395.7. Does anybody have any questions so far? Is anybody uncertain about why I flipped the second reaction?
why did you flip it though?
Well, take a look at the reaction that we want, Michael. You've got SO3 on the left side, right?
Mm-hmm.
But look where the SO3 is in the reaction we actually have. It's on the right-hand side. So
Okay.
I flipped the second reaction to get the SO3 to the correct side.
All right, thanks.
And that meant the sign changed here too.
Thank you.
Okay. Now, looking at this, the other thing that you'll see is the coefficients aren't what we need either. So in the reaction we have an SO3 with a 1 in front of it effectively, but what we need is a 2. So what I'm going to do is I'm going to take this reaction and multiply it by 2. You'll also notice there's a 2 in front of the SO2, so I'm going to go ahead and multiply the first reaction by 2 as well. So I end up getting, and I'll go ahead and 2s plus 2O2 gives 2SO2, and then 296.8, and rather than do it too much in my head here, I'll go negative 593.6. See, it retains its sign. I know I didn't put it in the calculator, but it doesn't really matter. And then the other one, I have to multiply that by 2 as well. So we'll end up getting 2SO3 gives 2S plus 3O2. And if I do the math on that, 395.7 times 2, I get 791.4. And what you'll notice here is that because I've got 2 S's on the left on this reaction and 2 S's on the right, I'm going to add the reactions together. The 2 S's will cancel because they're on opposite sides. I'll be left with 2SO3. Now looking at the O2s, I've got 2 O2s on this side and 3 on this side. So if you've got like terms and they're on the opposite side of an arrow, which is effectively an equal sign because these are reaction equations, then in essence, I end up with 1 O2 on this side plus the 2 SO2s that I already had from the other reaction. And then what I do is I add the delta H values together. And I end up getting 197.8, which is going to be the delta H of the reaction that I wanted. So you'll notice that as long as you follow the rules that I just set down, you really can't go too far wrong. Does anybody have any questions so far?
I do. So for the O2s, since they're on opposite sides, it counts as 1?
Well, since they're on opposite sides, you've got 3 on the right and 2 on the left. It's like having 3A on each and 2A on opposite sides of an equal sign. We just subtract 2A or 2 oxygens from each side.
Oh, okay.
Do you see what I'm saying?
Yeah, I see now.
Okay. Any other questions? Obviously, the order here on this side doesn't really matter. It could be 2SO2 plus O2 or O2 plus SO2. It's going to be the same thing. All right, let's see how you're going. I don't expect everybody to get this right away, but I want to get an idea of how many, what your understanding is at this point. So please go ahead and vote. I'll give you another 5 seconds. 5, 4, 3, 2, 1. All right, so that's where we're at. About half of you have completely got it, or at least you think you do, and 7 of you are in halfway. That's okay. That's okay. We'll get you. We'll try and get everybody to that. I understand completely kind of situation. All right. So that's a fairly simplistic example, I must admit. Let's look at something a little bit more difficult now. And we'll look at number 24 here. Now this one's a little bit tougher. It's got 3 reactions, and then you've got the final reaction down here. Now this one's going to have a wrinkle that the other one didn't have. And you'll see what that is in a second. All right, so now we have a bit of a better grounding about what we're looking for. This is the final reaction. 2HCl plus F2 gives 2HF plus Cl2. That's what we're looking for. We don't have the delta H for that reaction. We do have the delta H for these 3 up here. So we're going to manipulate these 3 in order to get this one here. So let's go through. We'll just, before we do anything, we'll just look at each portion of the reaction we want to see if everything's on the correct side and if it has the correct coefficient in front of it. So if we look at HCl, you'll notice that HCl doesn't appear in any of these other equations. So what that means is I can look at that one pretty safely, and I can see that the HCl is on the correct side, which is good. But the problem is that there's a 4 in front of it where we need a 2 in front of it. So I know what I'm going to have to do is take the first reaction and divide it by 2. So I'll go ahead and do that. 2HCl plus half O2 gives H2O plus Cl2. And I'll take the delta H here, which I'll put in kilojoules. And I will make it, I could probably do it on my head, negative 74.2. Okay, so I'll stop here for a second. Is anybody uncertain about why I did that? Why I divided the top reaction by 2? Is everybody okay with that?
Is it because there was a half O2 in it already? Or
No. It's because if you look at the reaction we want, Joseph, it's got a 2HCl, but the reaction we have has a 4HCl. So I want to make them the same. Is that all right?
Yeah, it's fine. Thank you.
Okay. Now look at the F2s, and I can see that I've got F2 here in the reaction I want, and there is only one reaction with F2, which is cool. That's this one. But you'll notice there's a half in front of it. What I'm going to do is I'm going to take this reaction and multiply it by 2. So that's going to be H2 plus F2 gives 2HF. And that's going to be negative 1200.0. Now remember, this is addition rules. So what happens is that it's going to be negative 600.0 plus negative 600.0. It's not really times 2. The 2 is a counting number, so it's not like that counts as significant figures. So it's not really multiplication. It's negative 600.0 plus negative 600.0, which is negative 1200.0 because it goes by smallest number of places past the decimal. Any questions so far? Anybody have any concerns about why I multiplied the second reaction by 2? I didn't flip it because it was on the correct side as well. The F2 is on the correct side. Okay. Now the third reaction, I'm not sure exactly what to do with it, but you can see that it doesn't contain anything that's actually in the reaction down here. So we know that everything in this third reaction is going to have to cancel out. But you'll also notice that if I left the reaction the way it is, there's no way that I can get that H2, the H2O, and the O2 to cancel because they would all be on the wrong side. So what I'm going to have to do, and this is the wrinkle I was referring to, I'm going to have to flip that third reaction. And that means that it becomes positive 285.8. Okay, I'll stop here for a second and make sure you understand why I had to do that. Does anybody have any questions? All right, so look what happens. The H2Os cancel now. The H2s cancel. The half O2s cancel. And all we're left with is what we need, which is 2HCl plus F2 gives Cl2 plus 2HF. And then we add up all of these values here. And we get negative 988.4. Does anybody have any questions? So on this worksheet, you can see the answers are all here, so you can see I did get it right, which is good. And it also shows you what you need to do in each step. Does anybody have any questions? All right, so you can do those as practice, right? And there's a bunch of them here. There's like 6 or 7 of them. They all have answers associated with them, which is good. There's also a website here where it'll bring up reactions, and you have to figure out the heat of reaction. So those are cool, right? And it'll give you new problems each time. That's good practice as well. This is in the Hess Law folder, by the way. And then we've got the Hess Law quiz as well. So I'm going to show you the Hess Law practice quiz, which I think is really good practice. I think I nailed this one. I think this one's a really good one. It's one of the best ones I ever did, actually, I think. I don't know if you'll agree, but I think it's a good one. All right, let's talk about the first question here, which has to do with delta H of formation. So let me tell you what delta H of formation is first. Now, this is something that is dealt with in the other topic, the first one that I want you to go over yourselves. Now, the definition of heat of formation and I'm going to modify this a little bit from the way I usually do it. I say the heat of formation is the energy gained or released during the formation of 1 mole of compound from its elements in their natural state. I know that seems like a lot, doesn't it? So it's one of those statements where you're looking at them and say, yeah, I know the meaning of each of these words, but when they're put together, I have no idea what the heck that means. It's actually not nearly as difficult as it appears. Let me give you an example. Let's say we've got CaSO4, right? CaSO4. Can anybody tell me what elements are present in CaSO? This is not a trick question, by the way. What are the elements present in CaSO4? Nobody can tell me, huh? Nobody knows the elements present in CaSO4.
Calcium, sulfur, and oxygen.
Yes, yes, calcium. Thank you. Calcium, sulfur, and oxygen. Okay. So that's what I mean. I mean, it's this is the reactions between all of these different elements. Now, the other wrinkle here, well, first of all, two wrinkles. 1 mole, and the fact is it has to be from its elements in their natural states. And where you might become a little bit scared here is thinking, well, gosh, I don't know the natural states of these elements. By natural states, I'm talking about, well, how do they appear in nature? Well, how are you supposed to know that? I mean, you're supposed to be able to memorize all these different elements and everything else. You know, it seems crazy. Dr. Musgrave's being very unreasonable here. I mean, how dare he ask us to know all these elements in their natural state? It seems absolutely maddening. Why would he do something like this? Well, the thing is, you actually don't have to. I'll show you exactly why you don't need these elements in their natural states. Test 3. I'm just opening another instance of this so I don't have to close down the quiz. All right, and these tables, which you don't have to memorize, of course, by the way. And there's a copy of this table in the heat, work, and enthalpy folder. So you'll notice that these are all heats of formation for all of these different compounds, right? This is what we're trying to find. What you'll notice, though, is that certain heats of formation here are 0, and the reason is because those are elements in their natural state. So what I'm saying is you can look at this table, and anything that has a 0 next to it is that element in its natural state. So if I'm looking up calcium, I find calcium here is all in alphabetical order. And the calcium form that has the natural state is calcium solid. And that has a delta HF of 0. Now sulfur, let's have a look at sulfur. Sulfur. Whoops, went too far. There we are, sulfur. There we go. Is S rhombic. Now you'll notice there's another, you've got S8 gas. Well, that's not the natural form. So rhombic. So that's the natural form of sulfur. That's the crystalline form of sulfur, by the way. And for oxygen, let's see what it is in its natural state. Oxygen. And you can see here we got O gas. No, that's not it. But O2 gas, that looks good. O3 gas is not it either. But O2 gas is what it would be. O2 gas. Now, this is 1 mole out in front here, and that's what we're looking for, 1 mole of the actual compound. And this isn't quite balanced. I need a 2 in front of the O2 to balance that. But if I look at I think I've got it here. I hope I have. Calcium sulfate, CaSO4, there it is, negative 1434 kilojoules per mole. That's what the number says right down here. And that's the equation for the formation of calcium sulfate, CaSO4. Does anybody have any questions? Okay. How's your understanding of heats of formation so far? Five, 4, 3, 2, 1. Okay. All right, so we'll continue on, and we'll see if we can do some examples and get this a bit clearer. So looking at this one here, we've got HGO. HGO. And we're being asked to come up with the equation for the heat of formation of HGO solid. So what I've got to do is figure out what elements are present in HGO solid, and it would be Hg plus O. Now I've got to go back and find the natural states as well, and I'll do that in a second. HGO solid. So I have to go to this table to find the natural states. And for mercury, Hg is mercury. There it is. The natural state is Hg liquid because it's got the 0 here on the heat of formation. So that'll be liquid. HgL, liquid. And O, as we discussed earlier, was O2 gas. And that gives HGO solid. And you can see here that gives negative 90.83 kilojoules per mole. The unit is up here, kilojoules per mole. Now this isn't balanced because you've got O2 here and we've got O here. And the only way I can balance that is to put a half in front of the O2. Now, you might be saying, well, hang on, can't I just put a 2 in front of everything to get rid of that half? Now, the problem is that would give you 2 moles of HGO, but the heat of formation is for 1 mole of the compound. So I have to adjust it so that that stays a 1. Okay, does anybody have any questions?
You would only multiply the O by 1/2 and not the other side, right? Not the
Right,
HG.
right. Because you see, if you do half O2, that gives 1 O, right? 1/2 times 2 is 1. That leaves 1 O over here on the other side.
But that doesn't change like anything else in the equation.
No. Now, the only reason I put a half in front of the O2 was to get the same number of O's on each side.
Okay.
And if you think about it, look at what O2 is. That's O2. What's half O2? It's just O, right?
Yes, correct.
All right. Does anybody have any other questions? It was a negative 90.83. Sorry about that. Anybody got any other questions? Okay. I'll do one more example here, and then I'll see how you're going with it. Let's take a look at this one. This is still part of the practice quiz down here. I think I went too far here. I know it's here somewhere. Here it is. Here it is, question 5. Okay. So I'm looking at TiCl4. TiCl4 gas, yes. And then I ask myself, well, what makes up TiCl4? It would be Ti and then Cl as the elements. But now I've got to find what those are in their natural states. So I go back to this table. I look for titanium. And I see that titanium solid is 0, so Ti solid. And then I look for chlorine. So I go back to chlorine here, Cl, chlorine. And I see the natural state of chlorine is Cl2 gas because that's the one with the 0. And to balance that, I need to put a 2 in front of Cl2 to give me the 4 here. And then I can just copy the heat of formation down off the table for TiCl4 gas. So I can find it, here it is. TiCl4 gas, there it is. Now remember there's two TiCl4s here. There's a gas and there's a liquid, so you've got to be careful which one you take. I'm going to take the gas because that's what I'm being asked for here in the question, and it would be negative 763.2. kilojoules per mole. So that's a heat of formation. So what does that number represent? Well, if I was to take 1 mole of Ti, 2 moles of Cl2 and mix them together and react them, that's the amount of energy that should be released upon production of 1 mole of TiCl4 gas. That's all that is. It's the heat of formation. It's exactly what it says it is. The heat released when this gets formed. That's what heat of formation means. All right, I'll do another poll here, see how you're going. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. All right. Anybody got any questions that can help them get to completely understanding this? Anybody got any questions?
So did we get the numbers from negative 763.2? Did we get it from like the chart?
Yeah. You have to open the chart to do this, Michael. You can't do it. You can't do it just without the chart.
Thank you.
And it has to be this chart. You can't just pick one from another place on the internet.
All right, thank you.
Because it could be different. Numbers could be different.
Yeah.
All right. Any other questions? Any other questions? All right. Let's look at some of the other problems here. So question 2, it says, consider the reaction below. To find delta H, you must do what? Flip equation 1, flip equation 2, flip equation 1 and 2, or flip neither equation 1 nor equation 2. So these are the 2 equations we have. Excuse me. And the third equation, this is the one we want, the one that has the unknown delta H on it. So you're looking at it and you're being asked, well, what do you have to do? Well, you can see it's all about flipping this one. It's about flipping, it's not about multiplying. So the question you're asking is, well, is C10H8 on the same side? On the right side? Yes, it is. That's good. What about the CO2? Is that on the correct side? And you can see the CO2 in the reaction we want is on the wrong side on equation 2. So it should be on the right. It needs to be, it's currently on the left. So I know from this one that my answer would be flip equation 2 only. Does anybody have any questions? Okay. In the next one, it's about multiplying. So let's see, multiply equation 1, multiply equation 2, multiply both, multiply neither. So I'm looking at it, I see C10H8, that has a 1 in front of it, has a 1 in front of it in the reaction we want, so I don't have to multiply that one. And the CO2 has a 10 in front of it, and a 10 in front of it, so that's okay. So the answer here would be to multiply neither equation 1 or 2. Anybody got any questions? And then for this one, you would just apply what we just did. You'd flip equation to not multiply any of them and then add the delta H's together, obviously taking into account the fact that we have to flip this sign as well, and that will give us the delta H for equation 3, which you'll express in kilojoules and put it in the box. Does anybody have any questions?
It's reactants minus products, right?
That's reactant. No.
I mean products minus reactants, right?
Actually, Code, not for this problem. For this problem, we're just adding the delta H's together that we get here.
Don't you flip equation 2 though?
You do, and it would be negative 1090.6 minus 906, but it's not about reactants and products. It's just about the delta H's for the reactions.
Oh, I see.
I think you might be getting mixed up with the calculation for heats of formation, which we'll look at in a bit. Okay.
All right, thank you.
Right, in the next, in these down here, we're looking just to see which one we have to flip. And you can see it gives you all different possible combinations of that. And in equation 4, this is what we're looking for. So I'm looking, first of all, for NO2, find NO2 here. Where's NO2? It's in equation 3. And you can see that NO2 is on the incorrect side. So I know I'm going to flip equation 3. Look for water, H2O. I see it's on the correct side, so I don't have to flip equation 1. And I'm looking for HNO3. HNO3 is on the correct side. So it looks like the only one I have to flip is equation 3 presently. Yeah, flip equation 3.
Why wouldn't you flip equation 2?
As it turns out, it's a good question, Joseph. As it turns out, once I flip equation 3, I'm in a position where the N2s will end up cancelling. See, the N2 will be on the opposite side once I flip equation 3. So if I flipped equation 2, it would bring the N2 effectively to the wrong side. You see what I'm saying?
Yeah.
Is it
Okay.
that way it's able to cancel out from one side, the end on one side, and cancel out the other end from the other?
That's right, Sarah. Did you notice how there's no N2 anywhere in the final equation we want?
Yeah.
So that had to go. All right. Yeah, so we flip equation 3 only. That would be the answer there. Now for multiplying, I look for the NO2 again. The NO2 has a 2 in front of it, so that's fine. I don't have to do anything with that. The H2O has a 2 in front of it, and you'll notice it has a 1 here. So I know I have to multiply equation 1 by 2. And again, in order to get these N2s to cancel, I don't want to multiply equation 2. So multiplying, all I do is multiply equation 1 by 2. So you're getting the idea. This is how you go through it. This is how you do the practice quiz. You'll get the credit quiz. You'll be able to do the same thing. Does anybody have any questions? Okay. I'm going to show you what this looks like on the test because I really believe that this might be the best way to present this to you at this point. You'll see on the test, it's actually a little bit more simplistic than the examples I've shown you here. And I'll show you what I mean by that in a second. I'll go over questions 1 and 2 after I've been over this on question 3 here. So this is the Hess's Law question, right? The one we're looking at. Okay. So I'll go over one of these. So we've got 2a plus b. 2a gives b plus c, and then you've got the other 2 equations here. We're looking for d plus g gives e. So I just want you to treat these as you would regular compounds, and you'll get the same gist what we were just talking about. So we look at the final reaction and we look for D, and you can see there's only one reaction that's got D in it. That's the second one. So I know that one needs to be flipped. The other thing I know is that reaction needs to be divided by 2. And the reason I know that is because it's 2E in this reaction and we only have E in the reaction we want. So what I'm going to do is I'm going to kill 2 birds with 1 stone here. And I'll do 2A plus D gives E plus 2F. And I'll flip the sign. So it was 250 kilojoules per mole. And I will divide that by 2, so it'll be negative 125. All right, I know I did a lot there. Does anybody have any questions about what I did there and why I did it on equation 2? Anybody got any questions about what I did or why I did it?
Can you just go over with just one time,
Okay.
just a little bit slower? Thank
Okay,
you.
so look at D. We're looking at D in the final equation here. I found D in the second equation here, only the second equation. I see that it's on the incorrect side, so I know I have to flip it. That's the first thing. I also see that D here has a 1 in front of it, where it's got a 2 up here. So I know I'm going to have to divide it by 2 as well. So I flip the reaction and divide it by 2. So what that means is that I change the sign here to negative 250, and then I divide that by 2, and that's how I get to negative 125. Is that okay?
Yes, thank you.
I look also at G, and G only appears in the third equation. It's on the correct side and has a 1 in front of it. So I know that that doesn't need to be modified at all, which is good. I'm just going to leave it the way it is. All right. Anybody got any questions? Now you'll notice that E is on the correct side now and it has the correct coefficient. Now, but I did what I did with A or with D. It's it helped E there as well. Now the next thing I have to do is look at the 2A gives B plus C and see whether or not that needs to be flipped. And you can see that it does, because if I don't flip this, if I just leave it with the 2A gives B plus C up here, the A's won't cancel. We know the A's cancel because they're not part of the final equation. So I am going to have to flip the first equation. B plus C gives 2A, and that gives negative 298 to flip it. Okay, I'll stop there for a second. Does anybody have any questions about why I flipped equation 1? So look what happens. The B plus C's cancel, the 2A's cancel, and what else cancels here?
2F?
The 2F's cancel, yes, there you go, thank you. So what we're left with is D plus G gives E. And then we add all these together and that comes up with the final answer. Does anybody have any questions? All right, where you at? Five, 4, 3, 2, 1. A couple of people don't like to vote. I suppose it's your right. Anyway, there we're at. Anybody have any questions? Anybody have any questions?
So how did we get negative 125?
That was from, you see how it's 250 over here, right, Michael?
Yeah.
So we flipped it. That made it negative. And then
so
divided by 2, that makes it negative 125.
So when you flip it, it's going to be negative.
Yes, it changes the sign. You flip it, it changes the sign.
That makes much more sense. Thank you.
All right. Does anybody have any questions?
I have one. It's just about phosphorus.
Mm-hmm.
Because the original form of phosphorus that has the 0 in the delta H, it doesn't have gas, liquid, or solid. It has a I think that's alpha white.
You're right. Mm-hmm.
So would we put alpha white for if it's
Sure.
on a test quiz?
Yep.
Okay, I just don't know what the alpha key is.
Oh, well, then you would just probably write alpha.
Alpha white.
But I think you could be pretty hopeful that it wouldn't appear on the quiz. But I think there would be there'd probably be some direction for you there, Joseph, if that happened.
Okay.
All right. Any other questions? There's a couple of different crystalline forms of phosphorus. One's called alpha, the next one's called beta. And one is considered to be a natural form, the other one isn't. All right. Any questions? Okay. Goody-o. All right, let's look at the other two questions here, the first two. So these are the ones that are based on the delta H from bond energies and heats of formation. So I'll look at question 1 first, and it's about calculating the enthalpy, which is using the heats of formation. Now, the heats of formation appear in these tables here, but I'm not asking you to use a table. I'm actually providing you with the actual values. Instead of providing you with the table, I'm giving you the values here in this table here. The S0 you can ignore because that's for entropy, and that's not what you're being asked for here. You're being asked for enthalpy, which is the delta H. Now, the delta H is, now that's where you use that formula that you were talking about earlier. Somebody, Coden, I think, was asking about that. So the sum of the heats of formations of the products minus the sum of the heats of formations of the reactants. So it's products minus reactants here to get the delta H, which is the enthalpy. So that's how we're getting it. So to do this is actually not that difficult. I'll write it all out. Delta H is going to equal, and I'll put the products in square brackets and the reactants in square brackets as well. The products are 4C, 5D, and 5E. So 4 times C, which is negative 40.82. Plus 5 times D, which is 61.75.
These two rules have to cancel.
And then E, 5 times negative 90.50. So that's the products minus the reactants, which is 4 times 92.58 and 3 times 22.78. Does anybody have any questions about where I'm getting any of these numbers from? Okay, so then you do all the math on that. And these numbers out in front, the coefficients, they're all counting numbers. So this is actually, it looks like it's multiplication, but it actually isn't. It's actually addition. It's really negative 40.82 plus negative 40.82 plus negative 40.82 plus negative 40.82. So they've been added together 4 times. That's how that works. That means that whatever answer you get here is going to be of the form of this, where you're going to have a number and then 2 places past the decimal. And the unit there would be whatever you've got, joules per mole. All right, how are we feeling about that?
So negative 40.82, is it like a positive?
No. I don't understand that question.
So is it when it says 4 times negative 40.82? Like, do we just do like a positive?
No. Now you put it in your calculator. You put it in your calculator like this: 4 times 40.82 and the plus minus sign. That's 4 times negative 40.82, Michael.
Okay, thank you.
Any other questions? All right, where are you at? Where are you at? Five, 4, 3, 2, 1, 0. All right, everybody voted, which is good. But there we go. Can anybody tell me if they have any questions about this that would help them?
Like, could we just do like one more problem to see if like it goes, if like I understand it really good?
All right, I'll re-roll this. So this gives you an idea about what you can do to practice, you see. It's a bit slow on here for some reason. There we go, test 3. Practice test 3. Preview. All right, so this gives you an idea. You can see that the numbers miraculously changed here. Okay, let's have a look. So for this one, it's going to be 2 times 82.66 plus 4 times negative 57.04 plus 3 times, oops, I did hit the wrong one, didn't I? Negative D is 14.57. There's a danger right there, isn't it? Plus 2 times negative 57.04. There we go, that's better. And that's minus, when we do the maths, 4 times negative 15.
3 times negative 57.4.
3E, you're right. Yeah, see? I just did that to make sure you were watching. So yeah, so 3 times, that's good, thank you. 4 times, let's see, negative 15.01, there we go, plus 5 times negative 65.1. Okay, does that look right? Anybody have any questions?
Is the 14.57 supposed to be positive?
It is actually, thank you.
Mm-hmm.
Yeah, because I hit what I did was I looked at the wrong one initially. I looked at negative 57.04. Then I corrected myself, but I didn't correct the sign. So now that looks correct. All right, has anybody got any questions?
No.
Okay. Let's look at number 2 here. I know that people don't like this one very much. I like it, but a lot of other people don't. All right. Now this one is the approximate enthalpy, and it's going to be based on bond energies, and the bond energies are here. And when I'm talking about the bond energies, I'll give you an example. It's C, says C single bond C is 347 kilojoules per mole. So what that means is that's the energy required to break that bond. It's also the energy that is released when the two C's come together and form a bond, which would mean it's negative 347 kilojoules per mole as well. Now, the formula with the bond energies is as follows. Delta H is equal to bond energies of the reactants minus the bond energy of the products. Now, you'll notice that is the opposite of the equation we just looked at, which was heats of formation. Now, the reason for that is bond energies are all about breaking bonds, whereas heats of formation are all about forming them. So it's the reverse of the previous one. So the bond energies of the reactants minus the bond energies of the products. Okay, anybody got any questions so far? I'm making the assumption that this is not the first time you've seen it, because you've looked at the resources that I provided to you to look at this. All right. And if anybody hasn't looked at anything, then shame on you. All right, so let's look at how we do this problem. Now, you might be saying, well, gosh, there's a lot of words here. I hate word problems. I don't know how to do this. If that was the case, you could always look at the video that comes along with this. There is a video, right? It's in the folder below this folder below this test, a little bit below. All right. Let's read and just try and do it one step at a time. You know, it's like my psychiatrist told me. You know, he said, I told him, look, I'm afraid of stairs. He said, look, just take it one step at a time. That's what we do here as well. So it says 5 C atoms joined together in a cyclic circular structure. Well, let's just do that then. C, joined together, C. There we go. With as many H's connected so that each C atom has 4 bonds on it. So each C atom currently has 2 bonds, so I need 2 hydrogens on each. One step at a time. Anybody got any questions? All right, how are you so far with this? Cyclic structure with as many hydrogens on it as possible. Okay, 5, 4, 3, 2, 1. Okay, so that's where we're at. Does anybody have any questions that could help them get to that full understanding?
This doesn't have to meet the octet rule, or does it still go with it?
No, it does. It does make the if you follow these directions, it will have the octet rule.
Okay.
But I'm not asking you to do that. What I asked you to do was put all the C's in a circle and then put enough hydrogens on so that each C has 4 bonds. All right. Sorry, go on. Okay, so then it says we're going to add as many O2 atoms as will be required to react to give CO2 and H2O. So basically it's this, plus O2 gives CO2 plus H2O. The only problem is that this is not balanced. So we do have to balance it. So what I would do is write out the molecular formula, which is C5H10, which I can get by counting up all the C's and H's, plus O2 gives CO2 plus H2O. And then I balance it. I put 5 in front of the CO2. I put 5 in front of the H2O. And then that would give me, let's see, for the oxygens, 5 times 2 is 10 plus 5 is 15, which is 15 over 2 O2 in order to balance that. And to balance everything, I have to multiply everything out by 2. C5H10 plus 15 O2 gives 5 CO2 plus 5 H2O. Oh, nasty. Sorry, 10H2O. There we go, it's better. But if you look at that balance, that's 10 Cs, 10, that should be 10 as well. 10 Cs. And then we've got hydrogens, we've got 20 hydrogens, 10 times 2 is 20. 15 times 2 is 30 on the oxygens. 10 times 2 is 20 plus 10 is 30. Does anybody have any questions? It's not like we haven't done this before. We did this back in test 2, balancing hydrocarbons. So I don't want to hear stories of people saying, oh, I've never seen this before in my entire life. Any questions? All right, so if I'll draw this out and I'll just do what I had up here. I'm just going to put the coefficients in front of it. Plus, and we've got 15O2, which is O double bonded to O. And I know that from over here, it says, which is O double bonded to another O, which gives 10 CO2s. It says CO2 is C double bonded to 2 O atoms. So it's 10 double bonded to C double bonded to 2 O atoms, and then 10 waters, which is H connected to hydrogens. And again, it's here, which is O single bonded to 2 H atoms. Does anybody have any questions? All right, so when we count up it's reactants minus products, I get, let's see, there's 5 CC single bonds. 1, 2, 3, 4, 5. So it's a total of 10 because of a 2 in front. So we'll have 10 CC single bonds on the reactant side. I'll write this up here, reactants. I don't want to maybe do that. Let me see. All right, so let's look at reactant side first. Reactant side. We'll have 10 by CC bonds, CC single bonds. Now hydrogen, CH bonds, we'll have, let's see, so there's 10 of those times 2 is 20, so 20 by CH bonds. And then we'll have 15 by OO double bond. And on the product side, we'll have 20 by C double bond O and 20 by OH. And we've got the values of those down here. We add them all together, apply the equation, and that gives us our final result. All right, questions? Questions? Well, I'd recommend doing that question again and again until you understand it. I know there's a lot of steps to it, but that's they're not that hard if you understand what you're doing with each step. All right, does anybody have any questions?
So just to make sure, it's like 10 times 347 and 20 times 414, and then we get it all together.
That would be on the
answer side.
Yeah, 10 times 20. Yeah, it's 10 times So this is on the reactant side. It'd be
Mhm.
10 times 347
Yeah.
plus 20 times 414 plus, we need the O, double bond O, plus 15 times 498.
Correct. Okay.
Right? That's on the reactant side. On the product side, you've got 20 times C double bond O, 20 times 736 plus 20 times O single bond H, which is 464.
Okay.
So I would add them up all separately and then do the subtraction and come up with the answer.
Okay.
All right. Anyway, I would recommend, well, nobody has any excuses now. We've been through all the material. You can start doing practice test 3. I would do it again and again and again. You know, the people who fail, it never ceases to amaze me. People who fail, they might have tried it once or never tried to practice test at all. I mean, that's craziness. That's absolute craziness. It just tells me that whoever it was who did that didn't put any time into anything. You have to put some time into this if you want to pass it. That's the message here. Does anybody have any questions? All right, we'll continue with the fun on Wednesday. Okay, continue with the fun on Wednesday.
I have one, but can I wait till the end of class?
Yeah, you might just talk to me after class, or
Okay.
All right, just hang around. All right, I'll see you all later. If you want to hang around, talk to me, you may, of course. I'll see you later.
Thanks, Professor.
Have a good day.
Thanks, folks. Have a good day.